Hi Geometry, this is page 390 of our workbook and this is Unit 3, Lesson 11. This is my favorite lesson in Unit 3. So let's talk about this triangle that we see on this page. It tells me that AC and MN are parallel, and I know that because I have these arrows right here. So remember what parallel lines, when they're crossed by this transversal, if you can imagine extending this line, I know that my angles that are in this position of corresponding angles are congruent. And so A and M are congruent in those spots. C and N are congruent because they're corresponding angles with parallel lines. So now let's think about our nested triangles that we've been talking about in our class. Right here, BNM is a smaller triangle inside of BCA. And I know B is in both triangles and it's congruent to itself. So what I have here is three angles of the little triangle congruent to three angles of the big triangle. So I know these two triangles are similar. So triangle BNM is similar to triangle, let's line up the same way, BCA. And this is by the angle-angle similarity theorem. I don't have to show any sides and proportions, so I don't need to write any ratios and reduce or anything like that. I just need to show at least my two angles. If I have two angles congruent, I know the third one's going to follow. So I'd like to talk for a moment about some ratios that are true in this triangle. So I want to talk about some ratios that must be equal. So I know, for example, that from the little, I'm going to write these little over big, but you could write big over little. That part doesn't matter at all. So BN corresponds to the big triangle side BC. So I don't know what that's equal to. I have no idea. Is that equal to 1/2? Is that equal to 1/3? Is that equal to 1/4? It kind of looks like it's going to be 1/2 just by looking at the picture, but I don't really know what it is. But whatever it is, whatever this length is divided by this length has the same value as BM divided by BA. Again, I don't really know what they are. Maybe, let's say it is 1/2. Maybe this is 4 and this is 8. Okay, great. But they reduce down to 1/2 or 0.5, just like this ratio would. And finally, let's not forget side MN goes over side AC. So I like to call this the whole over whole ratio. This was a whole side, the whole side of the little triangle over the whole side of the big triangle. And you could flip this. I could have made this BC over BN, BA over BM, and then AC over MN. And still, I would have equivalent ratios. So there's a new one today I want to talk about. We briefly talked about this in the practice of another lesson. I also have my parts of the sides. So I also can write part over part ratios that are equivalent. So up here, if I think about MN as basically dividing my sides into two different parts, I have BM here and I have MA there. I have BN here and I have CN there. Those are parts of the sides, and the ratio that they make are also equivalent. So I know that BM divided by MA or AM, here it doesn't really matter, and I know I could flip those, that would be fine, but since BM is at the bottom and so is BN, then I'm going to write BN on top too, so they're in the same place. And CN is on the top as AM was, so I'm going to write CN so it's in the same position. Order doesn't matter in this part at all. they have the same ratio. It's not going to be equal to these because this was the whole little side and the whole big side. This is a part over a part and a part over a part, but it's going to be true, and I can use it to solve problems. So this is called the triangle proportionality theorem. So let's write that down real quick before we keep going with this. So the triangle proportionality theorem states that if a line parallel to one side of a triangle intersects the other two sides, it divides the sides proportionally. So going back to this is really important and it's very confusing. We're going to do a couple problems where we're going to use this. Sometimes you write ratios and cross multiply and solve using the whole over the whole. So the little triangle and the big triangle. Sometimes you write proportions using part over part. Notice which side has nothing to do with this. Going back up to this right here, MN and AC, those sides aren't split at all. So when I use part over part, I'm only talking about when the parallel line goes through my triangle, intercepting two sides of my triangle, it splits those sides proportionally. That has nothing to do with AC and MN. So I haven't wrote any ratio that involves those two sides right here at all. So let's take a look at the next page and do these two problems. So in this problem, it tells me that A, B, and EF are parallel. It also tells me that AD and DB are perpendicular. This right angle is really important. That makes this little triangle a right triangle, and it also makes the big triangle a right triangle. So if I wanted to use the Pythagorean theorem, I could. So it says to find the length of each unlabeled side. So let's start by finding AB, and let's use the Pythagorean theorem to do that. So this is to find AB, and I'm going to use the Pythagorean theorem. A squared plus B squared equals C squared. The only number that has to be in a particular spot is my hypotenuse, which has to be C. That's my longest side. It's always across from the right angle, and that would be my AB. So this is where I'm going to put my AB. AB is acting like a variable. If you'd rather leave it C squared, you could totally do that. My sides are 3 and 4. It doesn't really matter which one's A, and it doesn't matter which one's B. The point is you're going to have a 4 squared plus a 3 squared, and that's equivalent no matter what order you put them in. So 16 plus 9 equals AB. That was squared. Sorry about that. Squared. And so I get 25 equals AB squared. And now I'm going to take the square root of both sides, and I'm going to get that 5 equals AB. So I know that this is 5. So let's keep going with this problem. I'd also like to find this side EF. This is the entire side of the big triangle. So in order to find EF, I'm going to write a proportion that uses whole sides over whole sides because EF is part of my entire triangle. So I'm going to use my 5 over EF because they go together. And I'm going to set that equal to, so now I need a side in the little triangle and the corresponding side in the big one. I only have one that I can use at this time. I know this side in the little triangle is 3, and I know DE, the entire side, is 7.5. So I'm going to use 3 in my numerator simply because the 5 was over 7.5. There are 4 ways to write this proportion that would be correct. So now I'm gonna cross multiply, and I get 3 times EF equals 5 times 7.5. Doesn't matter which side you put them on. We get the same answer. And then 5 times 7.5 is 37.5. And then let's divide both sides by 3. And I get 12.5. So this side right here is 12.5. So let's also find BF. So to do that, BF is not the entire side of any triangle. It's a part. So DB is 4 and BF I don't know. These are 2 parts of my side. Their ratio is going to be equivalent to the 2 parts of this side. So I know this is 3, but I don't know this part. So if the whole side is 7.5, then 7.5 minus 3 is 4.5. I know AE is 4.5. So I'm going to write a proportion that puts AD over AE, and I could flip those if I wanted to, but I'm going to write 3 over 4.5 equals, so since I put the 3 on top, the 4 has to be on top on the other side, and since I put the 4.5 on the bottom, then the bottom part of this side is going to go in the denominator, and that's my BF. And so now I'm going to cross multiply, and I get 3BF equals 4 times 4.5, and I have 18. So my BF equals 6. So now that I have that, I also know this entire side DF. So I could also say what DF is simply by adding the 4 plus the 6 I just found for BF means DF would be 10 units. And I have now found the length of all the segments of my triangle. Let's do the same thing for number 2. So why don't you pause the video, stop the video, read this, and try to find all the parts. You're going to find BE, ED, you're going to find the entire side, and why don't you also then find each of these parts as well. Find every segment of the triangle and then come back to our video. Welcome back. So let's look at some of your answers. So it was important that these 2 lines are parallel. So I know my 2 triangles are similar and all these proportions are true. EG was 12, EB was 2.5. I wrote those in purple. And then everything I wrote around the triangle in green, I calculated. So hopefully you got 4 for ED, and then you could subtract and get the 8. Hopefully you got 7.5 for this whole side, and you could subtract and get the 5. So on EF, I want to pause for a minute because I'm going to guess you probably did a whole over whole ratio and a whole over whole ratio, meaning the entire side of the little triangle to the entire side of the big triangle. I'd also like to find EF by doing a part over part ratio. So if I wanted to do part over part, 4 and 8 are the 2 parts of this right side. And so I could start by writing those. I could write 1/2 if I wanted. It does reduce to that. And 2.5 and something I don't know right now, because I haven't done any calculations yet, let's say, 2.5 and something else make up the 2 parts of this side. So I would write my 2.5 over that would be BF. So not the whole side, EF, but this little part. And then I could do my calculations and I would get 5 equals BF. So that's an important measurement. It's this little part. And then I could add the 5 and the 2.5 together, and I'd find that the entire side is 7.5. There's lots of ways to work around these triangles as long as you can use the whole over whole or part over part ratios correctly to write your proportions. On the summary on page 392, it wants us to be able to find the measure of FC. So let's see if we can find FC. Let's write in some measurements we know. We know the entire side BA is 9. So I know this whole side is 9. I also know BG, this little portion right here, is 3. That means GA would be 6 when I subtract 9 and 3. And then it says that BF is 4. So let's say I'd like to find FC, either because I want to know what FC is, or maybe I'm going to decide to add them together and get BC. So it's one way to find that. I can also find, if I wanted BC, I could also do 3 over 9 equals 4 over BC if I wanted to do that. But let's find FC. So this is a part over part setup. So I'm going to take my 3 over 6. Could you write 1/2? Sure, it's what it reduces to. So you already know that FC is 8. Great. But let's look at our setup for problems that have numbers that aren't as nice as these. So over here then, it'll be, since I put the 3 on top, I have to put the 4 on top on the right. And so then since the 6 is on the bottom, the FC will be on the bottom. Notice I didn't use the 9 anywhere, because 9 is the entire side of the big triangle. If I knew FG, if I knew AC, there's also nowhere for those values to go in a part over part ratio that I'm going to use to set up a proportion to solve. So I have to use just the parts of the two sides that I have there. So when I cross multiply, I get 3FC equals 24. And as we predicted then, FC is 8. So I know that FC is 8. I also know then that BC is 12. Thank you.